The National Electrical Code does not explicitly forbid the use of THHN wires within enclosed metal structures. However, a fundamental principle of the NEC mandates that all wiring must be installed within the raceway or an otherwise approved enclosure. The rationale behind this requirement is that exposed wires are vulnerable to damage, creating a potential fire hazard. Considering the described scenario, THHN wires are powering lights within a square metal structure. The absence of a raceway and the lack of support for the wires constitute a violation of the NEC, thereby posing a fire risk. When utilizing THHN wires in enclosed metal structures, adherence to proper installation practices within a raceway or an approved enclosure is paramount. Failure to comply with these regulations could lead to a fire. The NEC Article 300.3 addresses conductors and requires that they be insulated. This means the conductors must have an approved insulation. Type THHN wire is an approved insulation. Also, Article 300.11 addresses securing and supporting. Raceways, cable assemblies, boxes, cabinets, and fittings must be securely fastened in place. Firstly, raceways and cable assemblies must be supported from the building structure using straps, screws, or bolts. Secondly, raceways must not be supported by ceiling grid support wires or the ceiling grid itself. Additionally, independent support wires are permitted for attaching raceways. Article 300.14 covers the length of free conductors at outlets, junctions, and switch points. At least 6 inches of free conductor, measured from the point in the box where it emerges from its cable sheath or raceway, must be left at each outlet, junction, and switch point for splices or connection of equipment. Article 300.15 pertains to raceways and cable fittings. A box or fitting is required at each conductor splice connection point, outlet, switch point, junction point, or pull point for the connection of conduit or the raceways. Exceptions exist, such as for cable splices in manufactured wiring systems or for equipment as permitted elsewhere in the code. Article 310.15 focuses on ampacity. Conductors must be sized to carry the load they will be subjected to. Ampacity is the current, in amps, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including firstly, the size of the conductor, secondly, the type of insulation, thirdly, the ambient temperature, and fourthly, the number of conductors in a raceway or cable. Table 310.16 provides ampacity ratings for insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air and installed in raceways or cables. Adjustments and corrections to these ampacity ratings may be necessary based on ambient temperature and the number of current carrying conductors in a raceway or cable. Article 314.16 discusses the number of conductors in outlet device and junction boxes and conduit bodies. Boxes and conduit bodies must be large enough to provide adequate space for the conductors installed in them. The maximum number of conductors permitted in a box or conduit body is determined by the size of the box or conduit body, the size of the conductors, and the number of devices installed in the box or conduit body. Volume calculations are also necessary to determine the correct size box to use. Article 334.10 covers uses permitted for non-metallic sheath cable, types NM, NMC, and NMS. Type NM cable is commonly used for residential wiring. It may be used in normally dry locations. Type NMC cable may be used in dry, moist, or damp locations. Type NMS cable may be used for both power and signal circuits in residential occupancies. All non-metallic sheath cables must be protected from physical damage. Article 334.12 describes uses not permitted for non-metallic sheath cable. Non-metallic sheath cable must not be used in hazardous locations, in corrosive environments, in houseways, or embedded in concrete, plaster, or aggregate. Article 358.10 covers uses permitted for electrical metallic tubing, also known as EMT. EMT is a thin-walled metal raceway that is commonly used for both exposed and concealed wiring. EMT may be used in dry, damp, and wet locations, but it must be made of corrosion-resistant material if used in a wet location. EMT must be supported and secured properly using approved fittings. Article 358.12 describes uses not permitted for EMT. EMT must not be used where it will be subject to severe physical damage or in hazardous locations, unless specifically permitted elsewhere in the Code. Article 370.13 describes securing and supporting outlet boxes and conduit bodies. Outlet boxes and conduit bodies must be securely fastened to the surface on which they are mounted. They must be supported by one of several methods, including firstly by being mounted to a structural member of the building, secondly by being embedded in concrete or masonry, thirdly by being supported by a raceway, or fourthly by other approved means. Article 392.10 covers uses permitted for cable trays. Cable trays are typically used to support large numbers of cables in industrial and commercial applications. Cable trays may be used for service, feeder, and branch circuit conductors. They may be used in both exposed and concealed locations. Article 392.12 describes uses not permitted for cable trays. Cable trays must not be used in hoistways or were subject to severe physical damage. Article 392.20 covers the cable installation requirements within cable trays. Cables installed in cable trays must be securely fastened to the tray. The cables must be installed in a neat and workmanlike manner. Cables must not be stacked too high in the tray, which could cause overheating. Article 392.30 discusses grounding cable trays. Cable trays must be grounded in accordance with Article 250. This is to ensure that the cable tray is at the same potential as the equipment it is serving, which helps to prevent electrical shock hazards. The general requirements for wiring methods are found in Chapter 3 of the National Electrical Code. These requirements cover everything from the types of wiring methods that are permitted to the methods of installation. Some of the more common wiring methods include firstly, rigid metal conduit, secondly, intermediate metal conduit, thirdly, electrical metallic tubing, fourthly, flexible metal conduit, fifthly, non-metallic conduit, sixthly, cable trays, seventhly, wireways, and eighthly, cable bus. The NEC also provides requirements for the installation of conductors. These requirements cover everything from the size of conductors to the methods of splicing conductors. Conductors must be protected from physical damage. This can be accomplished by installing the conductors in a raceway or other approved enclosure. Conductors must be supported at intervals that prevent them from sagging. Conductors must be identified. This can be accomplished by using color-coded conductors or by marking the conductors with tape or other approved means. The NEC also provides requirements for the installation of boxes and fittings. These requirements cover everything from the type of boxes and fittings that are permitted to the methods of installing boxes and fittings. Boxes and fittings must be sized appropriately for the number of conductors that will be installed in them. Boxes and fittings must be securely fastened to the surface on which they are mounted. Boxes and fittings must be accessible. The NEC also provides requirements for grounding and bonding. These requirements cover everything from the methods of grounding and bonding to the size of grounding and bonding conductors. All electrical equipment must be grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. All metal parts of electrical equipment must be bonded together. Bonding ensures that all metal parts are at the same potential, which helps to prevent electrical shock. In the situation described, the THHN wires are not enclosed in a raceway and they are not supported by any other means. This is a violation of the NEC and it could create a fire hazard. The wires should be installed in a raceway, such as electrical metallic tubing or rigid metal conduit. The raceway should be properly supported and secured. The wires should be sized appropriately for the load they will be carrying. The wire should be identified. The box where the wires terminate should be properly grounded. The NEC specifies minimum sizes for conductors based on the ampacity of the circuit they serve. For example, Table 310.16 provides ampacity ratings for various conductor sizes and insulation types. If the circuit is rated for 20 amps, and using THHN copper conductors with a 75 degrees Celsius rating, a minimum of 12 American wire gauge wire would be required. For a 30 amp circuit, an American wire gauge would be the minimum. These sizes ensure the wires can handle the current without overheating. Overcurrent protection, such as circuit breakers or fuses, is critical for preventing fires and equipment damage due to overloads or short circuits. The overcurrent protection device must be sized to protect the conductor. For example, a 12 American wire gauge THHN copper conductor with a 20 amp ampacity should be protected by a 20 amp circuit breaker or fuse. The NEC provides specific requirements for the type and size of overcurrent protection devices based on the conductor size and the application. Grounding ensures a low impedance path for fault current to return to the source, which allows the overcurrent protection device to trip and de-energize the circuit quickly. All metal enclosures, such as junction boxes, equipment frames, and conduit, must be grounded. Grounding is typically achieved by connecting a grounding conductor from the enclosure to the grounding electrode system. Bonding ensures that all metal parts are electrically connected, creating an equipotential plane. This helps to minimize voltage differences and reduce the risk of electric shock. Bonding is typically achieved by connecting metal parts with bonding jumpers or by using approved bonding fittings. The location and environment in which the wiring is installed can affect the type of wiring method required. Firstly, in dry locations, non-metallic sheath cable, electrical metallic tubing, or rigid metal conduit may be used. Secondly, in wet locations, conductors with moisture-resistant insulation, such as THWN or XHHW, must be used, and raceways must be made of corrosion-resistant materials. Thirdly, in hazardous locations, explosion-proof wiring methods must be used. Proper installation of wiring requires careful attention to detail and adherence to the NEC. It is always best to consult with a qualified electrician if you have any questions about electrical wiring. Firstly, planning is essential. Before starting any wiring project, it is important to plan the layout and determine the correct wiring methods and materials. Secondly, safety should always come first. Always turn off the power to the circuit before working on it. Wear appropriate personal protective equipment, such as safety glasses and gloves. Thirdly, neatness counts. Install wiring in a neat and workmanlike manner. This will make it easier to troubleshoot problems in the future. Fourthly, testing. After completing the wiring installation, test the circuit to ensure that it is working properly. If the THHN wires are not installed in a raceway, they are vulnerable to physical damage. This could lead to a short circuit, which could start a fire. The NEC requires that all wiring be installed in a raceway or other approved enclosure to protect it from physical damage. A raceway is a channel that is designed to hold and protect electrical wires. Common types of raceways include firstly, conduit, secondly, tubing, thirdly, cable trays, and fourthly, wireways. In addition to protecting wires from physical damage, raceways also provide a path for grounding. This helps to protect people from electrical shock. The NEC also requires that all electrical equipment be grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and de-energize the circuit. This helps to prevent electrical shock and fire. The lack of support for the wires could cause them to sag or come loose. This could also lead to a short circuit or a fire. The NEC requires that all wiring be supported at intervals that prevent it from sagging. Wires can be supported by a variety of methods, including firstly, cable ties, secondly, straps, and thirdly, clamps. In the described scenario, the THHN wires are being used to feed lights inside a square metal structure. The wires are not enclosed in a raceway, and they are not supported by any other means. This is a violation of the NEC, and it could create a fire hazard. If you are planning to use THHN wires in a close metal structure, you must make sure that the wires are properly installed in a raceway or other approved enclosure. Failure to do so could result in a fire.